Okay, here we've got two spheres colliding, S and T, and the point of contact is in that direction. We've got initial velocity of S, which is u at an angle of 60. So I'll split it into u sine 60, u cos 60, the two components. So afterwards, we know that the component in the direction of impact will change, but the horizontal one in this case will not change. So that remains of u sine 60, and this direction is, we'll call it v1, and this one we don't know the velocity either, but we know it will be directly in line with the direction of impact, v2, and the mass of both objects is the same. So using the conservation linear momentum, we don't need to worry about the horizontal because it's the same in both. In fact, there's not just one component, it's the same component. So we're looking at m times u cos 60 is the momentum before, and momentum afterwards is m times v2 plus mv1. So clearly we can get rid of the m, so u cos 60 is v1 plus v2. Cos 60 is obviously a half. So if we now look at the impact law, so speed of separation is v2 minus v1 equals the speed of approach, which is u cos 60 times e. So difference of speed when they approach is this, times e gives you difference of speed or velocities afterwards. Okay, so we now have two equations we're interested in, and 1 and 2. Let's rewrite those out a bit better. So equation 1 is v1 plus v2 equals a half u, and equation 2 is v2 minus v1 equals a half u e. Okay, so we can find v1 and v2 in terms of e now. So if we add them, I think we need both anyway, so I'll add them, and I'll get v1s will cancel. 2v2 is a half u 1 plus e. So v2 is u 1 plus e over 4. And v1 can either substitute it back, but v1 equals, to rearrange the second one, or the first one doesn't matter, v1 equals a half u take away v2 from the top one. So it's a half u take away u 1 plus e over 4. Let's get a common denominator of 4. So we're going to have a half is 2 over 4. So it's 2u take away u take away eu all over 4, which equals 1 minus e lots of u over 4. Okay, so we've now got v1 and v2. So now it asks you for the speed of s. So we've got v1 and we want the speed. So speed of s here is, using Pythagoras, square root of v1 squared, which is the direction in one way, plus the direction in the other direction, which is u sine 60 two components, and we're going to square root it. Okay, now it's just a matter of a little bit of algebra. Here we've got a u squared over 16, so let's mess around a little bit. So we've got u squared 1 minus e squared over 16 plus u squared, sine of 60 is root 3 over 2, so it's 3u squared over 4, and we're going to square root that. Now we're going to make this into 12u squared over 16, so I'm going to replace that with 12u squared over 16, and now we're going to take a u squared out of 16 out of the square root bracket. Square root of u squared over 16 is u over 4, leaving 1 minus e squared plus 12, which equals u over 4 square root e squared minus 2e plus 13. Okay, and the speed and direction. Okay, so we've got to find the speed of t as well. Speed of t is a lot easier. Because we know the direction, it's only got this one component. So speed of t is just u 1 plus e over 4, because it's just in the one direction. Right, now, we've now got to find the angle which it's deflected through. Okay, so what we've got is, let's draw on the vertical, or whatever point of contact. We know this one comes in at 60 degrees. And we know it goes out oh, did I find the direction? S. Don't think I did I? So I'm going to have to do direction of S in a moment. But what we're going to be doing is we know that S went in this direction. This was from before. Okay. U sine 60, and we know this was our V1, so this is the direction it travelled in. So we are looking to find theta here. Theta here. That's the direction we're interested in. It's the same angle there. So the direction of S travels is going to be the arc tan of u sine 60 over V1. Okay, which is tan to minus 1 of root 3u over 2 over u 1 minus e over 4. Multiply top and bottom by 4. And we get tan to the minus 1 of 2 root 3 over 1 minus e, as we cancel the u's. Okay, so that's the direction of S. So that's the angle theta. Alright, so now we're looking for delta, so the angle of deflection. we're looking for an effect here. So it would have carried on in this direction here if there'd been no impact. So that delta is this angle here. Okay, right, so we want the largest delta. So the largest delta is when theta is the largest. Okay, because further around here. So at the moment it's deflected there, but if it's deflected even further, then delta increases. So we want theta to be largest. So we want theta to be 90 degrees. For theta to be 90 degrees, that implies E equals 1. And then finally delta will be 90 degrees. Take away the 60 degrees we had previously. So it's a 30-degree deflection. Okay, because we know this is 60, this bit here. If the whole angle is 90, 60 plus the 30 will make the 90-degree angle we've got. A bit tricky that bit, I think.